So number 1 up here, the first problem that is, you should get that the final population is 1,024 times the starting population. And then for the second one, I'm thinking it's 1, 4, 1, 4, 2, 1. Is that correct? So,
wait, I didn't get that.
So let's talk about the sister formula, the half-life decay. It's exactly the same, guys. The only difference is instead of a 2 being here, it's a half, because instead of doubling every so often, it's being cut in half every so often. So go ahead and write down this. Okay, so once again, N represents the final amount, the quantity that's left after T years have gone by. N naught represents the starting amount once again. T represents the total time again. H is our new letter because it represents the time it takes for the material to be cut in half. So let's go ahead and see how this applies. Go ahead and write down number 1, please. So the key word here that indicates we're going to use the half-life formula instead of the double time growth formula is, of course, the phrase half-life. So this is how things are dated. It's called carbon dating. They use it to determine how old things are. So this says the half-life of carbon-14 is 5,730 years. How much of a 10 milligram sample will remain after 4,500 years? So let's go ahead and see how this plays out. Since it's a half-life question, we're going to use the half-life formula. All right. So do they tell me my final amount? No, they don't tell me that, so that's going to stay exactly as it is. Do they tell me my starting amount? They say we have 10 milligrams to begin with. So I'm going to replace N naught with 10. And 1/2. Well, that's going to stay exactly the same, but we have the letters now. T is the total time. Do they tell me how long we're going to be letting this thing decay for, the total time?
4,500.
It's going to decay for 4,500 years. And do they tell me the half-life of this element? They tell me it's 5,730. So, once you figure out what all the variables are, you're good to go. You want to follow your order of operations. Do the exponent first. And after that, do your multiplication. So, let's go ahead and work it out. First of all, if I do 4,500 divided by 5,730, let's see what we get. It's going to be a decimal answer. We get 0.79 if we round to the hundredths place. So I'm going to go ahead and change slides here. So we have N is equal to 10 times 1/2 to the 0.79 power. And then we'll go ahead and raise the 0.5 to that power, or I mean the 1/2. So if it helps you to think of 1/2 as a 0.5 at this step, since we're using our calculator, go ahead and rewrite it as a 0.5. So 0.5 raised to the power of 0.79 is 0.58. And then if we multiply, we'll get our final answer, which is 5.8 milligrams. And that's how much would be left if we let it decay for 4,500 years. If it started off at 10 milligrams and we let it decay for 4,500 years, then we'd have 5.8 milligrams left. Go ahead and write down number 2, please. Now number 2, number 1 is really, I just kind of did that to kind of show you guys how to plug stuff in and simplify. But now number 2 is more like a real life application, because on number 2 I was looking, well, we found the final amount, right? That's not usually the question. What do they usually use these half-life formulas to find?
How long
They usually use it to find out how old something is, right? So this time we're going to be solving for t, which is an exponent. Whenever you have to solve for an exponent variable, we're going to use our logs. Okay, so logs going to come into play here. All right. Now, a lot of times they will round the 5730, which I believe is the actual half-life of carbon. They'll round it to 6,000 years just to make the calculations a little simpler, so there you go. All right. If the half-life of carbon-14 is 6,000 years, how long would it take 100 grams to decay to 12.5 grams? Let's see. All right, so the first thing we're going to do is we're going to plug in all the information that they give us. So we have a half-life formula, because the question pertains to half-lives. And let's see what we got. Did they tell us the final amount?
Yes.
What?
12.5.
That's right. The final amount is 12.5 grams. That's what's left after it's decayed. And what did it start with?
100 grams.
It started out at 100 grams. Now, do we know the total time? No, that's the part I don't know. I don't know how old this thing is, how long it's been decaying. So that's going to stay as a T, but I do know the not the D, it's an H actually. I do know what the half-life is. What's the half-life? We're rounding it off to 6,000 years. So, there we go. So we have 12.5 equals 100, and in parentheses, 1/2 raised to the t over 6,000. So let's go ahead and change slides and solve this thing. Yes, we're going to change this to log form. But before we do that, we have a little bit of cleanup to do. I'm just going to change this to 0.5 if you guys don't mind. That's a 6,000. Let me rewrite that so it's a little more legible. Okay, so now before I can do the log form thing, I need to get that 100 out of there, so it's just a number being raised to a power instead of a number being raised to a power times another number. So how would I get rid of this 100? Divide it out on both sides. So that's going to give me 0.125 equals 0.5 to the t over 6,000. Now we're going to change this to log form. All right? So here we go. What's the base? The base is the thing that's being raised to a power. So what's the base? 0.5. And the antilog, what's the thing that we're taking the base of there? The thing it equals, right? 0.125. And then it equals the exponent, which is all right. Well, my calculator doesn't have a base 0.5, but luckily we know change of base. So change of base, you do log over log. Which one goes on top? 0.125, and 0.5 goes on the bottom. And we'll use our calculators to figure out what that is. So log 125 divided by log of 0.5, and I'm getting 3 exactly. Now if you are kind of doing it piecemeal, you might get something pretty close to 3, but not exactly. But you can just take my word for it there, it's 3. One more thing to figure out how old this thing is. We have t over 6,000 equals 3, so how can I find t?
Multiply 6,000 on the other side.
Yep, just cross it off the bottom here, multiply it to the other side, right? Which gives me a total of how long?
18.
So it would take 18,000 years for 100 milligrams to decay into, what was it, 12.5 milligrams. Some? Here's some for you.